Hi friends, welcome back. Today we are going to solve one very famous and popular coding interview question asked by Amazon, Google, Microsoft, Facebook and many other companies. It's on Leetcode 36 valid Sudoku. So as you can see from the like dislike ratio, this is quite popular coding problem in the interviews as well. So we will implement this problem using Java in today's session. We'll discuss how we can solve the valid Sudoku problem along with some examples, so you will clearly understand how to the logic and the Java solution to solve this problem in today's session. Before we start looking into the problem details along with some examples and Java code, I want to mention that this channel is to help people in their coding and Java interviews. On this channel you will find lots of helpful videos that can help you in your coding as well as Java interview preparation. For example, there are more than 400 different varieties of coding problems solved and explained. Many of those problems are previously asked coding questions by Google, Facebook, Amazon, Apple, Microsoft, Yahoo, Lyft, LinkedIn, Uber, Netflix, and many others. You will find all important coding questions varieties in those solved problems, including breadth first search, depth first search, graph problems, binary search tree problems, coding questions related to binary search, linked list, strings, optimization problems using priority queues, dynamic programming questions, as well as lots of logical problems. So if you are preparing for any coding rounds of interviews or Java rounds of interviews, or you simply want to learn different concepts along with Java programming and problem solving, then this channel can definitely help you in doing so. So please subscribe to this channel now. Also, whenever we come across any important and interesting coding problems such as this one, we create videos to share our logic approach and the Java solutions with others, so they can also learn by watching those videos. So make sure you click on the bell notification icon so you always get immediate notifications for all our upcoming interesting videos. So let us start with this Leetcode 36 valid Sudoku. Determine if a 9 by 9 Sudoku board is valid. Only the filled cells need to be validated according to the following rules. Each row must contain the digits 1 to 9 without repetition. Each column must contain the digits 1 to 9 without repetition. Each of the 9 3 by 3 sub-boxes of the grid must contain the digits 1 to 9 without repetition. Note, a Sudoku board partially filled could be a valid but is not necessarily solvable. Only the filled cells need to be validated according to the mentioned rules. So this is what the problem statement says. They have given us one nice this example of Sudoku board. So we'll go there. Let's take a look at the constraints. So the board dot length is 9. So total rows are 9, total columns are 9, and the ijth is digit 1 to 9 or dot. Dot is basically empty, empty thing, right? Like as you can see, empty cell. So to understand this problem more, we can go and take a look at this first example, right, on the whiteboard. So this is the first example. I just took it from there. So if you look at this matrix, right, this is a 9 by 9 matrix, right, and this is a valid Sudoku board. So what is a valid Sudoku board? Basically we'll understand this. So basically what they are saying is each row, like this row or this row, any row right here, and every row actually, right, every row, they have all unique numbers, right? You can see 537, 6195, 986. Any row you take any row, you will see unique numbers 4195, here 879, right? So every row has a unique numbers. Similarly, if you take any columns also, every column has unique number here, 56478. If you go here 396, if you go here 8, if you go here 184, if you go here 796218. So every row and every column has a unique numbers, right? That is the first requirement. We should not get anything repeated. If you have a repeated number, it cannot be a valid Sudoku, correct? So that is what the rules say. Now apart from that, there is one other rule here, right, to be a valid Sudoku. What that rule says is there are subgrids here, subgrids of size 3 by 3, right? So let us read that here, right? 3 by 3 sub boxes of the grid must contain digits 1 to 9 without repetition. So where are those sub boxes here? So they have shown us sub boxes in this like bold red, black color, right? I'll just make it red for you. So this is a sub box of 3 by 3 matrix, right? This is one sub box. This one is another sub box, right? This one is another sub box. Then this is all are 3 by 3 grids basically, correct? You can see it now, right? These are the sub boxes. Similarly, you can go here. This is also another sub box of 3 by 3. This is another sub box of 3 by 3, and this is another sub box or 3 by 3, right? So these are all sub boxes of 3 by 3 size, right? And these are other three. So total you can see that there are 9 such a sub boxes here, right? 9 such a sub boxes, correct? uh, so what they are saying is in each of these sub box the number should be unique. If you see these sub boxes, you will not see anything repeated there, right? 3 5 6 8 9, nothing is repeated. 4 7 8, nothing repeated. 6, nothing repeated. Through 2 3 6 8, nothing repeated. 1 5 7 9, no repetitions. 1 4 9 8, no repetition. 5 7 9 2 8, no repetition. 1 3 6, no repetition, and 6, no repetition. So how I have to validate all these sub boxes of size 3 by 3, right? And we have to make sure that there is no repetition there. If there is no repetition, there is no repetition in every column and every row, then it is a valid Sudoku. That is what the logic is to find out if it's a valid Sudoku or not. Now, see, the finding each row has a unique number. It's very easy basically, right? And each column has a unique number. This is also very easy finding that, right? Because the size is just 9 by 9 basically, correct? So size is just 9 by 9. Let's take a look one more time to the constant say. So it is not variable. It is just always 9 by 9 size, right? So finding every row has a unique number and every column has a unique number is very easy. How will we find out if these 3 by 3 subgroups have unique numbers, right? That is the question to solve now. So how will we identify those? So I'll show you how to identify those. So basically, if you just look at this matrix now as a, instead of 9 by 9, you can consider it as a 3 by 3 matrix. So if it is 3 by 3 matrix, for the size of subgroups, right? Sub boxes, we will consider it. So this is zeroth row, this is first row, this is second column, right? Zeroth column, first column, second column, basically, right? Where the row is actually contains 3 rows, right? Each row contains 3 rows. Each column contains 3 columns here, right? Now, correct? So this is how we will solve that. So we have to now identify. Uh, so now if we look at a cell, right, how will we identify which subgroup that belongs? So we will need two things to identify a subgroup, right? We need the which row is that and which column is that, right? So for example, if you look at this one, right, if you look at this one, this is zeroth row and zeroth column, right? Zeroth row and zeroth column for the 3 by 3 subgroups or sub boxes we are talking about now, right? So this is 0 through 0th column, correct? Now instead of that, if you go here, and if you look at this, this is a first row and first column, basically first row and first column, correct? For the subgroup, okay, subgroup we are talking about, each subgroup is of size 3 by 3, okay? So now this is first row and first column, correct? So but how we will identify this now? So I'll show you now. So let us consider this cell now, right? This cell. So which in reality which row is that? 0 1 2 3, third row, right? This is third row. And which column is this? 0 1 2 3 4, right? No, 0 1 2 3 4, fourth column, right? Third row and fourth column. So we will divide this by 3. So if you divide this by 3, it will tell you which row is that and which column is that, right? So now this is first row basically and first column, correct? So that is how we will identify which subgroup is that one, correct? If you go here, if you take this cell, right? If you take this cell, which row is this? Third row. I'll write down here, third row, correct? Same row, right? And column is 8th column, correct? 8th column. 8th column. Again, if you divide this by 3, it will tell you which subgroup is that. How we will know now? This is first row and second column, correct? If you look at it, this is first row and second column, correct? So this is how you can recognize which group, which subgroup that cell belongs to, right? If you go here, right, if you go here, which one is this? Let us see. So now this one is sixth row, right? Sixth row, and this one is seventh column. So we'll again divide it by 3. If you divide it by 3, you will get the subgroup position. So this is 2, this is 2. So this is 2 comma 2, second row and second column. For the subgroup, we are talking about subgroup. Clear? Okay. So now this is how we will recognize which subgroup that belongs. And once we recognize which subgroup that belongs, then we will create a map, right? To like this, it will look like that. I shown you on this right side. This is how our map will look like. This is subgroups that I am showing you, correct? So now you understood how to calculate the subgroup, right? So I'll remove these colors. So now I'll show you how actually once you create a map, how the map will look like, correct? So let us see how the map look like. So if you go to this 0,0 subgroup, we will map it into the map like this. So this is the subgroup, right? 0,0, and it will hold these cells, right? 3, 5, 6, 8, 9. If you look at this one, 3, 5, 6, 8, 9, all these cells we have captured in the map. This is a map, right, for subgroups. This is a map, right? And the key is this 0,0 is the key in the map, right? So it is basically how we will map this actually as a key. We will use a linked list, right? We will use a list there as the key, right? And list will have two values, the row and column, right? That's how we will identify which subgroup or which subbox is that. Okay, so now you saw this. Now if you take a look at 0,1, you can go to 0,1 here, right? This is 0,1. It is 1579. You can look here, 1579, correct? So you are following it, right? Now 1,1, let's go to 1,1. This is 1,1. What is this? 2368. So 2368, you are following it, right? Now let's go to 2,2. So this is 2,2, right? What is this now here? 25789, 25789, right? So this is how we will capture all our sub boxes. We will call that as a sub boxes here, right? Sub boxes, which is essentially subgroups, right? Sub boxes, and this each sub box size is 3 by 3, right? That is given to us in the problem itself. And since it is a map, this is a map, we can easily identify if we are getting any repeated thing, right? Because this one is actually a set, this one is set, so we can easily tell if it is anything gets repeated, we will immediately identify it. If we have something repeated, it's not a valid Sudoku, correct? So now you understood the complete logic. So I'll show you the Java code now. So it's not that difficult to solve this problem once you understood the logic, right? So now let's go back to our code, and we'll see the code, how we will implement it in Java, this one. So this is our code for the valid Sudoku. So we have created, this is our isValid Sudoku method is there. We'll return true or false, and they give us a word, right, which is a character 2D array. Now what we are doing, first thing here is we are creating 3 maps. So first we will look here, right? So this is first thing we will look, right? This is a column map, right? It will give us the column, which is 0 to 8 columns are there, right? The key is integer, and we will use hash set of characters, right? And same thing we will do for a row map also. Row map is there, column map is there. So this one is pretty straightforward and easy, right? Now this one is a sub boxes map that I shown you, right? Now this is the key is list of integer here, because we need two things to identify, right? For example, if you go here, we need the if you go here, right, you need column row and column, right? Row and column, two things you need. So that's why we will use a list here, right? List. So now this is the list is the key, and the value is again the hash set of characters, right? So now you understood this so far. So now we will go in the 2 for loops, right? We are traversing through the matrix or through the grid, right? Right, through the grid. So 0 to 9, because 9 by 9 size is there of the board. It's a fixed size board, right? So we will keep reading each character now. The current value here, we have read ij value from board, into the current value, right? Now grid index is the one that list I was talking about. This list I just showed you, 2 comma 2 list. So this one we have to calculate now for each cell, right? So we are calculating that for each cell here, right? Grid index dot add I divided by 3 will give us row, correct? So this will give us row of the sub box, right? Sub box, this one is important, right? Row of sub box, and this one will give us column of sub box, right, of the sub box. So now we got column and row just by dividing by 3, and we stored that into our grid index list, right? Now we will check if this current value is dot, then we will simply continue, right? Dot means it is an empty cell, then we don't have to do anything, correct? Now if it is not a dot, then we will check if it is a valid Sudoku or not, right? That value should be valid Sudoku. What we will check in this valid Sudoku thing, we will check that the column, like this column should not have this repeated value, the row should not have the repeated value, and the sub box should not have a repeated value. Three things we have to check basically, correct? So now first thing we are checking it here is the column should not have the repeating value, so we are checking it here. If column has the repeating value, because call map.getJ will give a set, and we'll check in the set if it contains current value, it is basically repeating, we will return false. Otherwise we will keep checking. So column is fine, then we will check into row, right? If this row has that value repeating, how we will check? Row dot get I will give us the hash set, and if set contains the current value, it means that it is repeating, right? We will return false. Now these both things are okay, then we have to now still make sure that the sub boxes also should not get the repeated value, right? So this is what we will check now. So how we will check sub boxes of grid index? So grid index is the list, because for sub box map the key is the list of integers. Remember, it is a list of integer is the key here, right? So this key, that's why we have created this grid index key here, right? Now we will use that key and we will check into our sub boxes map. If that key will get so sub boxes map dot get grid index will give us the set, right? Set it will gives us. So we'll check into this set. If it contains current value, it means that it is repeating, right? We will return false. If nothing is repeating, we are good, then we will add those values into the corresponding column, row, and the subgroup map, right? Sub boxes map. So let us go through this logic. So now nothing is repeating, everything is good. So we'll go and add this into column. So call map dot get like contains j means it's already existing column, then we will just add into the column. If its column is not there, then we will have to first create that blank like a new hash set, and then we will add that value, correct? First time. This is first time for that column, right? Here same thing. If the row already is there available, then we'll just go ahead and add this value into that row set, right? If the row set is not yet created, like for the example first time, right, then you will create that hash set, and then you will add the value into the hash set here, right? Now we have added for column, we have added for row. Now we have to still add for sub boxes, right? So now we will again do the same thing. If sub boxes has already created for that group grid index ID, right? Grid index, then we will just add it into the grid index, the current value. If it's not already created, we will have to create a new hash set first, correct? We will create a new hash set here, and then we will add the current value into that grid sub box basically, right? Sub box we are adding. So clear, right? So this is way you will keep looping into this for loop, right? We'll keep each and every cell, and we'll make sure that each and every cell, the row is valid, the columns are valid, and the sub boxes are valid. If everything is valid and we reach here, we'll return true. If something is not valid, we will actually reach here and just return false, right? So this is the logic to solve the valid Sudoku problem. One very important coding questions asked by Amazon, Facebook, Google, and many other companies. So make sure you practice this problem if you are planning for any coding interviews. These are frequently asked coding problems. So we are now going to test this code, right? So let us talk quickly about what is the times complexity. So we are going to go through all these two for loops, right? So 9 into 9. So your fixed size 81 times you will go. right? Maximum 81 times you will go. The size does not change, right? So always you will go maximum 81 times in these two for loops. Other thing is now, if you talk about the space, then you have three maps here, right? So 9 is the column map, 9 is the row map size maximum, and sub boxes, the maximum will be total number of elements in this map will be 9 elements, right? Total maximum, correct? As you can see, these are 9, right? Count it: 1 2 3 4 5 6 7 8 9, right? Always maximum 9 elements. So you can just say that it's kind of a 9 plus 9 plus 9, so you can say 27, order of 27 is the space complexity here, because you have used this map. This size is not going to change, correct? So that's what you can explain in the interview. Size is maximum that much, and these two for loops maximum times it can execute is 81, right? 9 into 9. So this is how you can explain the time complexity and the space complexity for this code. I hope it is clear to you now. So this is the way our valid Sudoku solution will work. So let us test this code with some test cases, make sure it works. So this is the first one. First one is true. We are getting correct answer. Let's try with the second test case. This is the second test case. Right. Let's remove the first one. This is the second test case now. It should give us false. We are getting correct answer. Let us take the first one. We'll just do a small modification and make it false. So now, as you can see, first row has 7 here. If we make a 7 here, then it will get repeated, so it should return false. So we are getting false, which is the correct answer. We can just go ahead and submit this code to the Leetcode, make sure it gets accepted by the Leetcode. So the code got accepted by the Leetcode. It is 58% faster than the other submissions which are done online, uh, and 81% faster on the memory usage, which is a pretty good solution for this valid Sudoku problem. So I hope you completely understand these important coding problems. One very popular coding interview question by many big tech companies. Um, if you are new to this channel has a dedicated playlist for Leetcode and Leetcode problems and solutions. That playlist has more than 250 different varieties of coding problems solved and explained for your easier understanding. They come with examples and Java code. Java code is always shared through GitHub repository. You will find the Java solution code link available in the video descriptions, where you can go and check out the Java code, play with the Java code with different test cases for your better understanding of the code. You will find all different varieties of coding problems in those playlists solved and explained. Many of those problems are frequently asked coding questions by big tech companies including Google, Facebook, Amazon, Apple, Microsoft, Yahoo, Lyft, LinkedIn, Uber, Netflix, and many others. Apart from that, if you still want to practice more coding problems, on this channel there are 3 other playlists you can check. The names are Code Forces, Code Chef, and AdCoder. All in all, you will get more than 400 different coding varieties of problems you can use for your coding interview preparation as well as for your in-person interview preparation as well. Um, if you like this video, if you find this video helpful, if you like the way the video is created with this whiteboarding session examples and Java code and explanation, then please give it a thumbs up to the video, give it a like to the video, subscribe to the channel. Your subscription is very important for the channel, because that is the way the videos can reach to more people who need help in solving coding problems. Some people find it difficult to solve different coding problems. Through this channel, we would like to help them by showing them how different coding problems can be solved using Java programming language, using different data structures, algorithms. So they can also learn by watching these videos how to solve different varieties of problems. So if you like this video, give it a like, share it as much as you can with your friends and colleagues. They can also watch these videos, they can also learn from these videos something new, something more about problem solving, programming, and data structures. If you like the videos on this channel, if the videos on this channel are helping you learning something new about Java programming language, data structures, algorithms, and problem solvings and logic building, then write into the comments below the description section. Comment on these videos and tell us about it, how the videos are helping you. That motivates us to create more such good quality content for others. So let us know how the videos are helping you in your interview preparation process as well as in your learning process. Whenever we come across any interesting and important questions like this one, we create videos and post it on this channel so that we can help others also understanding how to approach and solve different coding problems using Java. So make sure you click on the bell notification icon so you always get notifications for all our upcoming videos. Keep coding, keep learning, keep solving different problems, and thanks for watching this video.